Digital and analog outputs. Blink an LED with digital output. This program uses a forever loop to repeatedly turn the LED connected to built-in LED IE pin 13 of the Arduino on and off with a delay of 1 second between each state change. When the LED is turned on, the set built-in LED to high block is executed, and when it's turned off, the set built-in LED to low block is executed. The wait 1 secs block causes the program to pause for 1 second before executing the next block. This creates a blinking effect on the LED. This circuit requires one Arduino Uno, an LED, and a 220 ohms resistor. This schematic shows a simple circuit for controlling an LED with an Arduino Uno. The Arduino's digital pin 13 D13 is connected to a red LED D1 through a 220 ohm resistor R1. The other end of the LED is connected to ground, U1_GND. The resistor R1 is crucial for limiting the current flowing through the LED, preventing it from burning out. When digital pin 13 is set to high by the Arduino, current flows through the resistor and LED, causing it to light up. When the pin is set to low, the current stops and the LED turns off. This is a basic setup often used for testing and demonstrating digital output on Arduino boards, as many boards have an onboard LED connected to pin 13. To develop an electronic circuit, please follow the steps outlined below. In the Components panel, drag a resistor and LED onto the workspace. Edit the resistor's value by adjusting it to 220 ohms in the Component Inspector, which appears when the resistor is selected. Back in the Components panel, find and bring over an Arduino Uno board. Click once to connect a wire to a component or pin, and click again to connect the other end. Connect your resistor to either side of the LED. If you connected your resistor to the LED's anode, positive, longer, connect the resistor's other leg to Arduino's digital pin 13. If you connected your resistor to the LED's cathode, negative, shorter leg, connect the resistor's other leg to Arduino's ground pin GND. Create another wire between the unconnected LED leg and pin 13 or ground, whichever is still not connected. The C++ code controls the built-in LED on an Arduino board. The setup function configures the LED pin as an output. The loop function then repeatedly executes. Inside the loop, digital write LED_built-in high turns the LED on, delay 1000, pauses for 1 second, 1000 milliseconds. Digital write LED_built-in low turns the LED off, and another delay, 1000, pauses for another second, creating a blinking effect. Multiple LEDs and breadboard. This program uses a forever loop to repeatedly turn the LED on breadboard through built-in LED pin of the Arduino on and off with a delay of 400 milliseconds between each state change. When the LED is turned on, the set built-in LED to high block is executed, and when it's turned off, the set built-in LED to low block is executed. The wait 1 secs block causes the program to pause for 1 second before executing the next block. This creates a blinking effect on the LED. This circuit requires one Arduino Uno, 3 LEDs, and 3 220 ohms resistors. This schematic shows 3 LEDs connected to an Arduino Uno. Each LED, D1 red, D2 yellow, D3 green, is connected in series with a 220 ohm resistor, R1, R2, R3 respectively, to a digital pin on the Arduino. D13 for the red LED, D12 for the yellow LED, and D11 for the green LED. The other end of each LED is connected to ground, U1_GND. The resistors limit the current flowing through the LEDs, protecting them from damage. This setup allows the Arduino to independently control each LED by setting the corresponding digital pin to high to turn the LED on or low to turn the LED off. To develop an electronic circuit, please follow the steps outlined below. Pick out components from the Components panel to add to your workspace similar to the circuit shown. Create wires connecting Arduino's 5V pin with the red plus power rail on your breadboard, and likewise GND with the black ground rail. To change your wire colors, select the color in the inspector, or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5V are typically red, and those connected to ground are black. Position your LED so the legs go to 2 different rows of the breadboard. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. Add a few more LEDs to this circuit, along with their companion resistors. For each, connect one end to ground and the other to a different digital input pin on the Arduino board. The C++ code controls 3 LEDs, the built-in LED and LEDs connected to digital pins 11 and 12, in a sequential blinking pattern. In setup, the pins for all 3 LEDs are configured as outputs. In loop, the built-in LED is turned on, while pins 11 and 12 are off. After a delay determined by the animation speed variable 400 milliseconds, the built-in LED turns off, pin 11 turns on, and pin 12 remains off. After another delay, pin 11 turns off, and pin 12 turns on. This sequence repeats continuously, creating a traffic light effect across the 3 LEDs. Fading LED with analog output. Pulse width modulation, PWM. PWM stands for pulse width modulation. It is a technique used in electronics and digital control systems to control the average power delivered to a device by varying the width of the pulse in a pulse train. PWM is commonly used to control the speed of motors, the intensity of LEDs, and various other applications where precise control of power or voltage levels is required. By changing the duty cycle, the percentage of time the signal is high, PWM can effectively regulate the output and achieve a desired level of control. The Arduino board can only generate digital signals, high and low. However, through the analog write function, we can simulate the appearance of varying brightness between on and off using PWM-capable pins. PWM works by creating an oscillating digital signal, alternately driven high and low in a repeating pattern. Each high to low to high period of time is called a cycle. The duty cycle of a PWM signal is the fraction of time that the signal is high during each cycle. This code creates a fading effect on an LED connected to pin 9 by counting up and then down in increments of 5, with a 30 millisecond delay between each change in brightness. The analog write function uses PWM to simulate varying brightness using digital signals. This circuit requires one Arduino Uno, an LED, a resistor, and oscilloscope. You can view the Arduino Uno schematic here. Let's learn to adjust an LED's brightness using one of the Arduino's analog outputs. You already learned how to use Arduino's digital I/O pins to send high and low signals to an LED, but some of these pins are capable of simulating a signal somewhere in between. These pins are labeled on the Arduino Uno with tilde symbol, next to the pin number. To develop an electronic circuit, please follow the steps outlined below. Identify the LED, resistor, and wires connected to the Arduino in the Tinkercad Circuits workspace. Drag an Arduino Uno and breadboard from the Components panel to the workspace, next to the existing circuit. Connect breadboard power, plus, and ground rails to Arduino 5V and ground GND, respectively, by clicking to create wires. Connect the LED cathode, negative, shorter leg, to one leg of a resistor. Anywhere from 100 to 1K ohms is fine. Connect other resistor leg to ground. Connect LED anode positive, longer leg, to Arduino pin 9. The C++ code creates a fading effect on an LED connected to pin 9. In setup, pin 9 is configured as an output. The loop function contains 2 for loops. The first loop increments the brightness variable from 0 to 255 in steps of 5, using analog write 9 brightness to gradually increase the LED's brightness. The second loop decrements brightness from 255 back to 0, similarly dimming the LED. A delay, 30, is used in each loop to control the fading speed. This continuous cycling creates the smooth fading in and out effect. RGB LED Color Mixing. This code uses a forever loop to repeatedly set the color of an RGB LED connected to pins 11, 10, and 9 on the microcontroller. This circuit requires one Arduino Uno, 1 RGB LED, and 3 220 ohms resistors. You can view the Arduino Uno schematic here. To develop an electronic circuit, please follow the steps outlined below. Add an Arduino and breadboard alongside the sample and prepare your breadboard by connecting Arduino 5V to the power rail and Arduino GND to the ground rail. Add an RGB LED from the component storage box and place it across 4 different rows of the breadboard. The RGB LED has a common cathode negative ground at its second leg, so wire this row/pin to ground. Add 3 resistors and move them to the breadboard rows for the remaining 3 LED pins. Connect wires from the free resistor ends into 3 of your PWM-capable Arduino pins, which are marked with a tilde, little squiggle. The C++ code controls an RGB LED connected to pins 9, 10, and 11 to cycle through cyan, magenta, and yellow colors. In setup, these pins are configured as outputs. The loop function then repeatedly sets the analog output values for each pin using analog write. Cyan is achieved by setting pin 11 red to 0 and pins 10 green and 9 blue to 255. Magenta is created by setting pin 11 to 255 and pins 10 to 0 and 9 to 255. Yellow is generated by setting pins 11 and 10 to 255 and pin 9 to 0. A 1-second delay follows each color change, making the transitions visible.